Okay, we had a little bit to finish up on the 4.4 notes where we were talking about complex numbers and the new strategy for how to solve quadratic equations, which we call the square root property. One of the things we did at the end of the last video is we were working our way through these 3 rules for working with complex and imaginary numbers. We had discussed that you always want your answer, final answer, to be in this standard form where the real number part is first, the imaginary part is second. It should always look in the end as a binomial. So we had things like I squareds that we change those I squareds into negative ones. The second rule is we never ever leave a negative number underneath a square root symbol. We always want to pull that out and express that as an I. What we're going to be discussing today is we're going to be looking at the third rule here, which is we are never to leave a radical in the bottom of a fraction. Okay, so, and you may have heard this before in geometry. If you have a fraction like 2 divided by the square root of 3, that is considered not a simplified radical. We don't ever want to leave a radical symbol in the bottom. Okay, now if we're talking about complex numbers, that means we have i's. Okay, if we're not supposed to leave a radical in the bottom of a fraction, what that means is we should never leave an I in the denominator of a fraction, because if you recall, an I is representing a square root of a negative 1. And so if we're not to leave square roots in the denominator, then we should not have i's in the denominator of our fraction. Okay, so you can see with the 3 examples here for number 8, you can tell that all 3 of these examples are kind of violating that third rule, because we see we have i's in the denominator of the fraction, and we need to come up with a way to be able to get rid of those i's. And so the way that we're going to get rid of the square roots, the i's in the denominator of a fraction, is we're going to be using what's called the conjugate of a complex number. So I want to make sure that first and foremost we're all comfortable with how to state what the conjugate of a complex number is. Okay, when you state the conjugate, what you're going to do is you're going to keep the real number portion of your complex number exactly the same. Okay, you're making no changes to the real number part. However, the imaginary number portion, you will simply flip the sign on that and make that the opposite. So for example, if I gave you 3 plus 8i, the conjugate of 3 plus 8i would be 3 minus 8i. So you can see how I kept the imaginary part the same as a 3, but then I did flip the sign on, I kept the real number part the same, but then I did flip the sign on the imaginary part, changing the plus 8i to a minus 8i. So let's just make sure that we are comfortable with that first. All we're going to do in example 7 is we're simply going to state what we think the conjugate of each of these 3 complex numbers would be. Okay, so if we have 3 minus 4i, the conjugate would be 3 plus 4i. The conjugate of 5 plus 8i would be 5 minus 8i. And be careful on this one. If it feels like they're not showing you the real number part, you can assume that the real number was in fact a 0. Okay, so this in example C is really 0 plus 4i. So the conjugate would be 0 minus 4i. And you do not have to show the 0. You could simply just write negative 4i. Okay, now here's the key with this. In order for us to get rid of these i's that are in the denominators of those fractions, okay, to eliminate an imaginary number from the denominator of a fraction, you have to take both the numerator and the denominator and multiply both the numerator and denominator by the conjugate of the denominator. Okay, so let's try this with example A. We first want to say, well, what is the conjugate of the denominator? Well, the conjugate of 3 plus 6i would be 3 minus 6i. So we're going to multiply this denominator by its conjugate, 3 minus 6i. Now it says here that we're not just multiplying the denominator, but we're multiplying also the numerator by that exact same thing. Okay, by the conjugate of the denominator. Okay, now what we basically have here is we basically have 2 multiplication problems. In the numerator, you're going to distribute this 2i to both of those terms, and I'm going to draw one big fraction bar. So we're going to distribute a 2i to the 3, and then a 2i to the negative 6i, giving us negative 12i squared. We'll come back and we'll simplify that a little bit more, but let's move to the denominator here. Okay, we kind of have a FOIL situation here in the denominator, where we're going to distribute this 3 to the 3 and the 3 to the 6i, and then we're going to double back and we're going to distribute the 6i to each of those. Okay, and this should be the 4 terms that we get in the denominator. Okay. Now keep in mind, somehow by multiplying the denominator by its conjugate, that should eliminate any i's that you are seeing in the denominator as we simplify. Now remember, it is okay to have square roots in numerators, so i's in the top are fine. We just can't have them in the bottom. So let's look a little closer here. Certainly this negative 18i and positive 18i will cancel each other out. If you recall from yesterday's video, we said I squareds result in a negative 1. Okay, that means we're taking the square root of negative 1 times the square root of negative 1, and we get just a negative 1. Now, I see a few I squareds here. Okay, I see one right here in the numerator. I see another one right here in the denominator. So what I'm going to do next is draw another fraction bar. I'm going to write out the numerator, but I'm going to replace those I squareds with negative 1s. Okay, so in the bottom, I'm going to keep this 9. And then I'm going to write negative 36, and then I'm going to change that I squared that comes after the 36 into a negative 1. Okay, so we're almost there here. Okay, keep in mind there is multiplication in between this negative 36 and negative 1, as well as this negative 12 and negative 1. So that means I'm going to have 6i plus 12, and in the bottom I'm going to have 9 plus 36. Okay, I'm going to reorganize this because when you write your final answer, you always want the real number to come first and the imaginary number to come second. So I want this 12 to come first and this 6i to come second. So I'm going to put the 12 first, the 6i second, and then I think my denominator is going to be a 45. I'm going to place the 45 separately underneath each of these two terms here. And then the only thing I have left to do is I'm going to simplify each of these fractions. And you could use your calculator. If you typed in 12 divided by 45 and then hit the math fraction button, it would spit it back to you in reduced fraction form here. Let's see. I think that this ends up being, that reduces to 4/15. And the fraction 6 divided by 45, that would reduce to 2/15. But don't forget, there is an I here that needs to stay with that. Okay, this would be considered to be an answer that would be abiding by all 3 of the rules that are in this box here. We wrote it in standard form. We have the real number part first, and it's completely separated from the imaginary part. We don't have any negatives left underneath square roots. We express those as i's, and we definitely got rid of radicals that were in the denominator. Okay, problems don't get any more difficult than that one. Okay, that one was pretty tricky. Let's go ahead and take a look at example B here. Okay, in example B, again, the strategy is to get rid of this I from the denominator. We have to take the numerator and the denominator and multiply each of them by the conjugate of the denominator. Now remember up here in this example where we couldn't see the real number part, the conjugate of 4i was negative 4i. So the conjugate of 5i is simply negative 5i. Okay, and that's what we're going to be multiplying both the numerator and the denominator by. So I like to always put things in parentheses. Okay, here it's kind of like we're distributing in the numerator but from the right side. So I'm going to draw a fraction bar here. Okay, we're going to distribute negative 5i to the 4 and then negative 5i to the I. Okay, in the bottom, we're going to multiply the 5 and negative 5 to get negative 25, and the I become an I squared. Okay, any I squareds that you see, and I'm highlighting them there, those should turn into negative 1s. So in my next step, I'm going to change each of those into a negative 1, okay, and then I'm going to multiply -5 and -1 gives me a +5 in the numerator. In the denominator, -25 times -1 would give me a +25. Now, if I left my answer just like this, it would kind of be violating those first couple rules. I don't have things in the right order. I think it's violating the first rule there. And I need to kind of separate things. I want this 5 to come in front of this -20i. So I'm going to put that in front and the -20i second. And then I'm going to put my denominator separately underneath each. And my last thing is just to reduce each of these fractions here. I'm going to reduce, whoops, sorry, this is just subtraction here. Okay, this would be a great answer for letter B. Okay, all right, let's take a look at this last one here. We are going to get rid of the I in the denominator by multiplying by the conjugate. Okay, so I kind of have some foiling happening at the top, some foiling happening in the bottom here. Okay, we're going to do a 2 plus 2i, then we double back and distribute this I. Okay, I'm going to do the same thing in the denominator. I'm going to distribute the 1, and then I'm going to double back and distribute the -i. Okay, now, these middle two terms in the denominator cancel. I see an I squared here. I see an I squared there. Okay, in addition, I think I could combine these middle two terms in the numerator so that that's going to make a 3i. And since this is a plus I squared, that's going to change into a -1. In the denominator, and you have to be super careful here, see how this is a minus I squared? That means we're taking a -1, and then when I change the I squared into a -1, I'm going to have two -1s that are going to ultimately make that in the denominator a +1. Okay. Also, I'm going to combine this 2 and this 1 into a 1. Okay, and so in the numerator, I have 1 plus 3i, and in the denominator, I have a 2, which I'll put separately underneath each. Okay, in this last example here, it says the table below shows several complex numbers where I is the imaginary number. Place a check mark in all the appropriate cells in the table where the product of the two numbers is a real number. Okay, so in other words, there would be no I in our answer at all. Now, I don't think we actually have to go through and do all of these problems. Let's just think about this here. Okay, we want to be able to say, if you take what's in this column, is there any of these three things that if you multiplied 8 minus 2i, you would expect the final answer to not have any i's in it? Now, think about what we were doing up here. What we learned is if you take a complex number times its conjugate, eventually when you work through these denominators here, you have no i's left in your answer. So if you take 8 minus 2i times 8 plus 2i, and you actually worked all that out, it should work out to just a real number. No i's. Okay. I don't know that we can put any more check marks down along the first column here. What about the 3? Anything we could multiply the 3 by where we wouldn't have any i's? Well, certainly the 3 and the -4, those would multiply together to be -12. And then the I think if you took I times 5i, you would get 5i squared, and the I squared would turn into a -1, so you would have a real number. So those are the three places where that check mark would be. Okay, I believe there